Welcome to Section 6.2, Solving Systems Using Substitution, Part 3. As a review, I'd like you to solve the system using substitution and check your answer. Notice that in this one, the second equation here had the y kind of all by itself. It didn't have a number in front of it except for this -1. So I subtracted 3x from both sides to get negative y equals negative 3x plus 4. Divide everything by -1 to get y equals 3x minus 4. We take that and we put it in for the x in our second equation. So, in for our y in our second equation. So we have negative 2x plus 5 times 3x minus 4 equals 19. You distribute to get negative 2x plus 15x minus 20 equals 19. Combine your like terms to get 13x minus 20 equals 19. Add 20 to both sides to get 13x equals 39. Divide both sides by 13 to get x equals 3. We know what x is, now we need to find y. So we use the second equation and we have 3 times 3 minus y equals 4. 9 minus y equals 4. Subtract the 9's from both sides to get negative y equals negative 5. Divide both sides by -1 to get y equals 5. We check by putting the 3 in for x, the 5 in for y. We have negative 6 plus 25 equals 19. That's a true statement, so we have our correct answer. Now, in today's lesson, we're going to review from the previous section the different possibilities that we could have when we solve a system of equations. We could end up with something that has one solution, no solution, or infinite solutions. When we did this with graphing, one solution looked like this, where we had one intersection point. How is it going to look in an equation? Well, it's going to look like the systems that we've solved the last 2 days. When we solve the system, we're left with x equals a number or y equals a number. That means we have one solution. No solutions looked like this on a graph. We had parallel lines. How is it going to look like in an equation? Well, when we solve the system, we're left with a false statement, something like 8 equals 2. Infinite solutions looked like this on a graph where we had 2 lines overlapping each other. How does it look in an equation? Well, when we solve the system, we're left with a true statement like 2 equals 2. So our goal today is going to be to figure out how many solutions the system has. Does it have one solution, many solutions, or no solutions? So again, we're going to use substitution to figure this out. Notice the first equation has y all by itself, so we're going to take the 2x minus 3 and substitute that in for y. So we have 4x minus 2 times 2x minus 3 equals 6. We're going to distribute to get 4x minus 4x plus 6 equals 6. The 4x minus 4x gives us 0, so tells me that 6 equals 6. That's a true statement, so we have infinitely many solutions. Let's take a look at another one. In this situation, we have negative x plus half y equals 13 and x plus 15 equals 1/2 y. Now here, we want to go ahead and solve for x. I'm going to solve for x in the second equation. So I end up with x equals 1/2 y minus 15, just subtracting y from both sides. Now that I have that, I can go ahead and substitute into my first equation. Negative, put the 1/2 y minus 15 in for the x, plus the 1/2 y equals 13. Distribute that negative to get negative 1/2 y plus 15 plus 1/2 y equals 13. The positive 1/2 y and the negative 1/2 y cancel out, leaving me with 15 equals 13. That's false, so therefore this system has no solution. Your assignment for this section is on page 372, numbers 26 to 31.